All right, so we're on 252, which is 5-4. This is the last section before the quiz. So we're talking about isosceles triangles and equilateral triangles today. That's what our ICANN statement says. I can use isosceles and equilateral triangles. We have vocab that we need to get out of the way first in terms of our isosceles triangles. So you see them here. Okay, the congruent sides of an isosceles are considered the legs. Okay, those are the legs of the triangle. And then the angles on each of those, okay, the angles, well, let's go the angle between, is the vertex angle. Okay, so you got the two legs of the triangle, and between that is your vertex angle. Okay, the other two angles surround the base. So the two sides that are congruent are the legs. The one that's not congruent is considered the base, and then the angles on that base are the base angles. Okay, it's important that we know these vocab words because when we see our theorems will mention base angles. We got to know which ones we're talking about. Okay? So you got your legs and your base, you got your vertex angle and your base angle. Now, even if the triangle is drawn a different way, right? Even if it's drawn this way, this is still considered the base. A lot of times we think of the base as being the bottom. That's not necessarily the case. Okay, we got the legs that are congruent. That third side is considered the base. Yeah.
What do they consider the base? Just the base, it's not congruent with the others?
Correct. Yeah, the base is just not congruent with the others. Yep. All right. So there's our isosceles triangle. Also, try to learn how to spell isosceles correctly. Okay, makes you feel better. There's an SOS in there, ISOS, and then CELES. It's not an easy word, but it makes you feel smarter when you know it. That's why you got to work on it. All right, so we've got those definitions. We're talking about isosceles triangles here. And this one is called the base angles theorem. The base angles theorem. In the old book, they called it isosceles triangle theorem because the base angle theorem only occurs in isosceles triangles. So base angles theorem tells us if we know the sides are congruent, then the angles opposite them are congruent. So if I know these two are congruent, then the angles across from them have to be congruent as well. Okay, that's going to hold true in every single triangle that you see. Sides are the same, opposite angles are the same. Okay, and that's base angles here. So we know that one. And then our second one is just the converse of that. So we've got the converse of that is, of course, the opposite, because that's what converse is. This is saying if I know those base angles are congruent, then I can say that the sides opposite them are congruent as well. So if I know the angles are congruent, then I can look at the sides across and say those are congruent as well. Okay. So they're very similar, right? Very similar. You just got to be able to tell the difference of when are we going to use base angles and when are we going to use the converse. That's the tricky part here, is knowing which one you're going to use when. So you got to know the situation that you've been given. Situation that you've been given. If it's base angles theorem, we are proving the base angles are congruent. If it's the converse, and this is the way that I think is the easiest to remember, the converse means you see the arc marks, and those arc marks are like little C's for converse. It's kind of cheap, but sometimes that helps. So the C for the arc mark, C for converse, this is when we see that, we have the converse that we're using to prove the size. However you decide to remember it, doesn't matter to me. All right, as long as you remember which one is which. Okay, that's the important part. All right, what if it's a right triangle? Which side is the base? So the only way that this would be a right triangle would be if these two are the same, right? If these two are the same, then these would be the legs and this would be considered the base. That hypotenuse would be considered the base then. All right. Any questions on our base angle or converse of base angle? Okay. Yep. So if we look at this figure, what two angles are going to be congruent? Awesome. F and E are going to be congruent. Right? Two sides are congruent, opposite angles are congruent. Good. So then we get to a corollary, and we already talked about this the other day. All right, I think Tyler brought it up. If something's equilateral, it has to be equiangular. Then it has to be equilateral, right? So we just have theorems for that. That goes off of the base angles theorem. Right? Base angles theorem is saying if you have congruent sides, then the opposite angles are congruent. Well, if I have three congruent sides, then all three opposite angles are congruent. So three sides, three angles, all congruent. So we know this is a fact. Okay? This is a corollary off of that base angle. If it's equilateral, it's equiangular. If it's equiangular, it's equilateral. So this stuff also applies to these equilateral triangles. So they're going to give you tough questions here, like this bottom one. Find the length of ST for the triangle. What's it going to be? 5. Wow, good job. You guys are good. You guys are good. Chill. Good, Brandon. Worry about yourself. Worry about yourself.
Never said that was.
So then, the rest of this here is just applying it, right? It's knowing the fact that you have congruent angles to be able to prove that the sides are congruent, set them congruent or set them equal to each other, and solve for your variables. Let's figure out what x and y are going to be here. If you haven't yet, give it to yourself until we talk about it together. We're going to solve for x or y first. Which one can we say first? Awesome. Y. That's 4, right?
Well, you could do X.
But why you can really get it up?
Yeah, you have to do other stuff before you can get that. Right? So yeah, y is 4. We know that because it's equiangular, so it's equilateral, so all the sides are the same. So I know all of these are 4. Now once I know all of those are 4, well now this side is also a part of this triangle. Since these angles are congruent, we're using converse of base angles to say that these two are congruent. So that we can set them equal, x of course is 3. Okay, so you're going to see ones like that, they're going to be harder, right? Where you're going to have to look at which sides do we have congruent, which angles do we have congruent, right? Going back and forth between those and knowing your connection. Okay. All right. So, next one that we see here, real world situation. We got a lifeguard, whatever. I don't know what to call that, but it's a lifeguard. And they're really working hard up there. Just chilling by the beach, real tough. So they're telling us that PS is congruent to QR, that's going to be this side and this side. It tells QPS. So QPS is going to be this angle, and PQR is going to be this angle. They're telling us that those are congruent. Okay. We want to explain how to prove that triangle QPS is congruent to triangle PQR. It's a little tough to see, right? Sometimes on this, and there are reasons why we show these types of problems. If they're overlapping, if your triangles are overlapping, and that's what's happening here. We're looking at triangle QPS. So we're looking at this triangle, right? And then we're looking at this triangle. So they're overlapping. What we can do is we can separate those if we'd like. We can separate those and label them. So we're looking at QPS, and then this side, if I take that one apart, we're looking at that one. And then we can mark in what we know. We know PS and QR. We know that this angle is congruent to this angle. By seeing them separated, we can maybe visualize a little bit better what information do we still need to be able to prove them congruent.
You can say P is congruent, PQ is congruent to QP.
Yeah, it's going to be PQ and QP here, right? Because those are the same thing. So when you look at that, we know we have to use SAS because that's the only thing we have right now. Side angle side, we know we have to say that this is going to be congruent to this. And when you look at the labels, you notice that they have the same exact endpoints. They're the same line, which means it's reflexive property. So PQ congruent to QP, reflexive property would get us there. Okay. And then the other question here says, explain why PQT is isosceles. So based on that information that we have, we want to know PQT, which is now this small triangle here. We want to know why is that isosceles? Luke?
Because the angle at P and angle at Q are congruent.
Yeah, the angle of the, so we know that the big ones are congruent, right? But since these triangles are congruent, we also know that these have to be congruent. And that's angle 1 and angle 2. Right? Because if you have congruent triangles, that means everything is congruent. So we've got angle 1 and angle 2 are congruent. Because those are congruent, that means the opposite sides are congruent by converse of base angles. And that allows us to say, yep, now we know that those are isosceles. All right. Yeah, sorry guys at home if it's a little blurry. That happens. It's not a great picture to begin with. We can try to get a little closer and just, block off people's view. But I try to do it off to the side so we don't have this glare thing here that takes up part of the board.
You could just close that window.
It's not from the window, it's from the projector. I tried. All right, just close the projector. Yeah.
Just tape them up to the board.
Good idea.
Probably solve it.
All right, here are the two things that I want you to look at. Okay, so here's our figure. They're asking for the values of x and for y here. And then we want to know why can we say, well, that's a different example. Don't do that one because we can't see it anymore. Ignore that one. Just look at this. We're trying to figure out x and y. Keep it to yourself. Think about it. Talk to somebody about it. What do you think x and y are going to be? Talk to somebody.
So Y is going to be, X is 6. And then Y would have to be,
40?
All right. What's X gonna be? That 60, right? Equilateral triangle means it's equiangular, which means all three have to be congruent. Since the total is 180, we know each one has to be 60. So we know this is 60. Okay, which means this is also 60. What's Y going to be here? Luke?
120.
120. Why is it gonna be 120?
Because you take the complement of 60 and then it's in the 90-degree angle and then it'd be the same thing.
Over here,
on the
right?
other side.
Yeah, because these are congruent, right? Because those sides are congruent, the opposite angles are congruent. So we know this and this have to be the same. So that's 30, that's 30. That's 60 total. We have 120 left. There you go. Good. Okay, any questions on that so far? Okay. Good deal. So, not a lot in this section. Okay, it's really what we just looked at, where it's looking at if these are congruent and the angles are congruent, or if the angles are congruent and the sides are congruent. It's just using that knowledge to be able to solve some questions. Okay. All right.